Hi guys, my name is IBM and today I'm deciding to record 970213 May June 2022 paper. These multiple choice questions, and without wasting time I would like to take you to the question paper. So here is the question paper for May June 2022 970213. So I will not go through the instructions, I will just go straight to the questions. Question number 1. Which pair of quantities are physical quantities? Of course, a physical quantity has a magnitude and a unit. Charge and ampere. Of course, ampere is a unit. Charge is a magnitude. We want a pair of quantities which are physical quantities. Efficiency is a quantity. Kilogram is a unit. Pascal is a unit. Strain is a quantity. Period is a physical quantity which has a unit. Potential difference is a physical quantity which has a unit. So the answer is going to be D. Period has a magnitude and unit. Potential difference has magnitude and unit. Which list of unit prefixes decreases in magnitude from left to right? Decreases in magnitude from left to right. So we know cent is 10 to the power minus 2. Dec is 10 to the power of minus 1. Mil is 10 to the power of minus 3. So decreases, the highest should be I think the highest is going to be, in this case, it would be dec. So dec is 10 power minus 1, 10 power minus 3, 10 to the power of minus 2. So it is, cent is bigger than milli. Pico is 10 to the power of minus 12. Kilo is 10 to the power of 3. Milli is 10 to the power of minus 3. So this one is a mixture. Kilo is 10 to the power of 3, mil is 10 to the power of minus 3, pico is 10 to the power of minus 12. So this one is decreasing. So the answer is going to be D. The drag coefficient CD is a number with no units. It is used to compare the drag on the different cars at different speeds. CD is given by the equation below. F is the drag force. Of course, we know the units will be kilogram, meters per second squared. Rho is density. We know the units would be kilogram per meters cubed. A is cross-sectional area. We know the units will be meters squared. V is speed. We know the units are meters per second. What is the value of N? So CD times V power N times density times area is going to be 2F. So I just equate the units. V is meters per second. This is to the power of N. Density is kilogram per meters cubed times area, which is meters squared, should be equal to, of course I will ignore the 2. Since CD has no units, I don't put it in this expression of units. Then F is going to be kilogram meters per second squared, so ignoring the coefficient 2. So I want to find N. I will easily use M power N. So M power N is going to be equal to, okay, I'm adding up the powers because of multiplication, so it is M power N minus 3 plus 2. On the left hand side I have M power 1. So it means N minus 1 equals to 1, which means N should be equal to 2. So my answer here is going to be B. N should be equal to 2. I equated the powers of M. N should be 2. A micrometer screw gauge is used to measure the diameter of a small uniform steel sphere. The measurement of the diameter is 5 millimeters plus or minus 0.01 millimeters. What is the percentage uncertainty in the calculated volume of the sphere using these values? What is the percentage uncertainty in the calculated volume of the sphere using these values? So we know volume of a sphere is 4 over 3 pi r cubed. They have given us diameter. So I will have to change the radius. I'll replace radius with diameter. So this will be 4 over 3 pi. Where there is radius, I put diameter divided by 2. And this is raised to power 3. So this becomes 4 pi d cubed divided by 3 times 2 power 3, which is 8. This becomes pi d cubed divided by 6. That would be the volume. Pi d cubed divided by 6. Okay. So we want the percentage uncertainty in the calculated volume of the sphere. So percentage uncertainty in V would be equal to 3 times the percentage uncertainty in D. Of course, I will ignore pi and 6. So this will simply be 3 times absolute in D, which is 0.01 divided by 5. Then I multiply this by 100. So 0.01 divided by 5 times 100 times 3, which is 0.6. So this is 0.6%. So the answer is going to be C. Forces of magnitude 2, 4, 7 combined produce a resultant force. The magnitudes of the three forces are fixed, but the forces may act in any direction in the same plane. What is not a possible magnitude of the resultant force? Of course, if they act in the same direction, the total will be 2 plus 4 plus 7, which is 13. So this one is part of the resultant. If two act in the opposite directions, of course. Okay, let's check the minimum. The minimum combination is when one points in one direction and one acts in the opposite, and two act in the opposite direction. That means the minimum resultant will be 7 minus 2 minus 4, which is equal to 1. That means the resultant should be between 1 and 13. For whatever combination, the resultant should be between 1 and 13. So this will be fine, this will be fine, this will not be fine. So that is not a possible magnitude of the resultant, because the range of the resultant should be from 1 to 13. Two projectiles X and Y are fired into the air from the same place on level ground and reach the same maximum height as shown. They reach the same maximum height as shown. Projectile X is fired vertically upwards and projectile Y is fired at an angle to the horizontal. Air resistance is negligible. Of course, if air resistance is negligible, the acceleration for both is simply g. Since there is no acceleration in the horizontal, the acceleration is only acting in the vertical. So they have the same acceleration, only that, of course, for both the acceleration is negative because they initially move upwards. So which statement is correct? X and Y are at rest at their maximum heights. This is not true because for the one projected at an angle at its maximum height, there is a velocity in the horizontal. It has a speed in the horizontal, so it is not at rest. But the one, of course, X will reach at maximum height, it will be 0. X and Y are fired with the same speed, X and Y are fired with the same speed. Of course, the initial speed for X is going to be different from the speed for Y, because Y is projected at an angle. So to reach the same maximum height, then they are not projected with the same speed. So this one is not true. X and Y take the same time to return to the ground. So because in the vertical, they travel the same vertical distance going up and down and the acceleration is constant, so C is going to be correct. X and Y will take the same time to return to the ground because the only force acting on these two is in the vertical, and the acceleration in the vertical for both is the same, and they have reached the same maximum height. If I use S equals to UT plus a half AT squared, and I consider vertical motion at the highest point for both, or maybe let me use V squared is equal to U squared plus 2AS. Of course, at the highest point for both, velocity is 0 in the vertical, and they have covered the same vertical distance, velocity is 0 for the vertical. So it means if velocity is 0 in the vertical at the highest point and they have covered the same distance, so it means the same vertical distance, so it means the time they are going to take to reach the highest point and coming back is going to be the same, since time is a scalar quantity. It doesn't depend on the direction, so the answer is going to be C. This one is saying X and Y travel the same distance. They don't travel the same distance, they have only the same vertical displacement. A small glider moves along a horizontal air. Someone may ask, why isn't the distance the same? The distance for X will be going up and coming back, that is twice. Yet the distance for Y will be the length of this path. And the length of this path is going to be bigger than the distance for going vertically upwards and coming vertically downwards. But if it was displacement, the displacement would be the same. A small glider moves along a horizontal air track as shown. Okay. At each end of the air track, the glider has perfectly elastic collision with a fixed buffer. So there's a fixed buffer this side and the other side. The glider moves at a constant speed, which means acceleration equals to 0. Which graph represents the variation with the time of the velocity of the glider as it moves between the two buffers? Because the speed, the acceleration should be constant, the speed is constant, the acceleration should be 0. The acceleration should be 0. That means the gradient of the velocity time graph should always be 0 at all cases. And the distance between the gliders, I think the distance is the same. Let me see. The glider moves at a constant speed between the collisions. The glider has a perfectly elastic collision now with a fixed buffer. So if we assume that the distance between the buffers is constant, it means the area under the graph should be almost the same. Okay, so let's look at the graphs here. So this one is showing the velocity has changed, yet should be constant. Velocity has changed, yet should be constant. So we have to choose between C and D. So if we assume that the distance between the buffers to the initial position of the glider, or the distance between the buffers is constant, is remaining constant, means the area under the graph should remain constant throughout. So this graph is wrong because the area here, the area has changed. So it means there has been a change in the distance or displacement. Yet the area should remain the same. So the answer is going to be D. The distance between the buffers has remained the same, so the area must remain the same. The area under the graph must remain the same. Okay. A car accelerates from rest. The graph shows the variation of the momentum of the car with the time. So this is momentum with time, and we know that force is the rate of change of momentum. What is the meaning of the gradient of the graph at a particular time? Gradient. So this is a graph of momentum against time. So it means momentum is equal to force times time. So if I have a graph of momentum with the time, it implies that the gradient, if I compare with the y, is equal to mx plus c. On the y-axis I have momentum, on the x-axis I have t, so it means the gradient is the force or the resultant force. So the answer is going to be C. A ball is dropped onto horizontal ground and bounces vertically upwards. When the ball is in contact with the ground, the following forces act: the weight W of the ball, the contact force P exerted on the ground by the ball. Okay, the contact force N exerted on the ball by the ground. Of course, these two, by Newton's third law, these two are going to be equal but opposite. the contact force N exerted on the ball by the ground, and the force P exerted on the ground by the ball. These two are going to be constant, so N should be equal to P. Okay, N should be equal to P. So that helps us to ignore A. N should be equal to P. That also helps us to ignore B, because N should be equal to P. N should be equal to P. Now, let's look at C and D. Remember, N should be equal to P. But then the ball, when the ball is in contact with the ground, the ball is momentarily stationary. At this instant, which relationship is correct? But here they said the ball is dropped on the horizontal ground and bounces vertically upwards. So it means if it bounces with time, it means the force which is going to be the force which is pointing upwards must be greater than the force which is pointing downwards. So it means we cannot say that N equals to W. That is not going to be true. So N cannot be equal to W, but we can say N is greater than W. So remember, W is the force on the ball from the center of the earth. And this force is not equal to N. So W is not going to be equal to N. Why? W is the pull of the earth on the ball, which acts at the center of the ball by the earth. The only force which is equal to W is the pull of the ball on the earth, which would originate from the center of the earth. So it is wrong to say N is equal to W. But then N could be greater than W. N could be greater than W if the ball bounces upwards. So N could be greater than W. In other words, the reaction force upwards is greater than the pull of the earth onto the ball downwards. A person stands on the edge of a high cliff that is next to the sea. The person throws a stone vertically upwards. Vertically upwards. Air resistance acts on the stone. It is vertically upwards, and the air resistance acts on the stone. What does that mean? If air resistance acts on the stone, so it means the acceleration must be, if air resistance acts on the stone, so it means the velocity must be actually decreasing. Air resistance acts on the stone. The stone eventually hits the sea. So the person throws a stone vertically upwards, and then it falls. The stone eventually hits the sea, so it means the sea is at the bottom. So it goes up and comes back. This is where we have the sea now. Which velocity time graph best shows the motion of the stone from when it is released until it hits the sea? So it first goes up, comes back. There's a change in the direction of the velocity. So let's check which graph. So C and D are going to be wrong. Why? Because C and D are showing that the velocity is in the same direction. It is on the same side. Then A is going to be wrong because A is showing that the acceleration here is constant. Yet air resistance acts on the stone. If air resistance acts on the stone, then the acceleration must decrease. And that means B is correct because B is showing that acceleration is decreasing since the gradient decreases. You notice that the graph is showing a decreasing gradient. So the acceleration is decreasing. But the acceleration is, of course, the acceleration is initially, it is showing acceleration in one direction, which is fine, but the acceleration is decreasing. That's what we're interested in because the gradient of the graph is decreasing. So the answer is B. Skaters of mass 80 kilograms, 40 kilograms move directly towards each other. Before collision, the heavier skater is moving to the right. So this one is moving to the right, and the other one is moving to the left. So it's moving to the right with a speed of 2 meters per second, and the lighter skater is moving to the left with a speed of 1 meter per second. After the collision, the heavier skater moves to the right. So after collision again moves to the right with a speed of 0.8 meters per second. What is the relative speed of separation of the two skaters? Okay, so we want to find the relative speed of separation. So I'll first consider conservation of momentum. We know momentum is equal to mass times velocity. Total momentum before collision is going to be, of course, velocity is to the left, to the right positive, to the left negative. So total momentum before collision is going to be 80 times 2 plus negative 40 times 1. I'm saying plus negative because velocity to the left is negative. The momentum is a vector quantity. So this should be equal to, after collision, we have 80 times the velocity to the right, which is 0.8, plus. The other one, we don't know its velocity after the collision, so I'll just say 40 times v. So what is v here? I'll just press my calculator. 80 times 2 minus 40. Then I'll subtract 80 times 0.8. Then I'll divide by 40. So that is 1.4. So v is 1.4 and it is positive. So it means it is to the right hand side. Okay, so if v is to the right hand side, now I want the relative speed of separation. Relative speed of separation, I will subtract 1.4 minus 0.8, which is going to be equal to, I think this is 0.6, which makes the answer to be A. Which statement describes the two forces in a couple? Remember, they should be equal but opposite. They don't need to be, they act in the same direction, which is not true. They act through the same point, may not be the case. They produce zero resultant force. They are equal but opposite. They produce zero resultant moment. This one is not true. So the answer is C, because you could have two forces acting in this direction about a fixed point, and they constitute what we call a couple. But the resultant moment is not zero because they can cause, for example, this could cause rotation about this point here. They could cause an anti-clockwise rotation about this point here. So the resultant moment does not need to be zero for a couple, but the resultant force is zero because they are equal and opposite. So the answer is C. A street lamp is fixed to a wall by a metal rod and a cable. Which vector triangle could represent the forces acting on the end of the rod at point P? So we have normal reaction force, we have the weight vertically downwards, and we have the tension here. So if I draw a vector triangle, I have a force which is vertical. Then I have a horizontal force. Then I have the tension, which points in that direction. So these forces should be pointing in that kind of pattern. So this one is wrong, this one is wrong. We have to choose between a C. C, unfortunately, this is pointing upwards, which makes it wrong. So the answer is going to be D. The answer is automatically D. An unknown mass and a 1 kilogram mass are fixed at opposite ends of a bar. The bar has negligible mass and length 30 centimeters. The bar balances when supported by a pivot placed 20 centimeters from the unknown mass as shown. What is the unknown mass? What is the unknown mass? Okay, so this is going to cause an anti-clockwise moment. Let the unknown mass be m. And if I just use masses, so m times perpendicular distance, which is 20, should be equal to 1 times the perpendicular distance, which is 30 minus 20, which is 10. So that is times 10. So m is going to be equal to 10 divided by 20, which is 0.5 kilograms, which is the same as 500 grams, which makes the answer to be C. A block of wood density rho W has sides of length A. The block is immersed in a liquid of density rho L. The top surface of the block is at a depth H. below the surface of the liquid. So it is fully submerged. That means the change in pressure is going to be a constant. The acceleration of free fall is g. What is the upthrust acting on the block from the liquid? We know that upthrust force is equal to cross-sectional area times difference in pressure, which is equal to cross-sectional area is A times A, which is A squared. Difference in pressure is density times G times difference in height. So this is going to be times density times G, difference in height, which is going to be A. That is H plus A minus H, which is A. So that is going to give us density times G times A cubed. So that is the upthrust. Density, and by the way, this is density of the liquid. Density of the liquid, not density of the wood, it is density of the liquid, because it is the liquid which is exerting we'll find the difference in pressure on the top and the bottom of the wood, and it is the liquid which is exerting pressure, so the answer is going to be A. This is density of the liquid. A technical article about diesel engines expresses the energy available from diesel fuel both as 41.8 megajoules per kilogram, that is 1 kilogram, produces 41.8 megajoules, and as 39.9 gigajoules per meter cubed, that is 1 meter cubed is equal to 34.9 gigajoules. What is the density of diesel? Density of diesel. So density is equal to the mass divided by volume. Density is the mass divided by volume. If 1 kilogram has that energy and 1 meter cubed has that energy, so what is the density here? So I want you to notice that density is mass over volume. If we bring in the concept of energy, this is going to be energy over volume divided by energy over mass, which is the same as energy over volume times mass over energy. I think mass over density is the same as mass energy over volume times mass over energy. So it means the density here is going to be the energy divided by volume, or energy per unit per meters cubed, which is 34.9 times 10 to the power of giga is power 9. This is the first quantity, E over V is that one, then divide by, so I'll just say divide by or multiply by the reciprocal. So I'll say divide by 41.8 times 10 to the power of 6, that is mega. So this is joules per meters cubed, and this is joules per kilogram. Okay, so I'll just divide this. So this is going to be 34.9 exponent 9 divided by 41.8 exponent 6. So this is 834.9 or 835. 8.35 times 10 to the power of 2. So which makes the answer to be A. What is meant by efficiency? Of course, that is useful energy output over total energy input. So difference between the useful energy output from the system, it is not difference, it is not difference. The ratio of the useful energy output from the system to the total energy input in the system, so that is efficiency. A car of weight 15,000 newtons is traveling along a horizontal road. At one instant, the thrust force acting on the car from the engine is 12,000 newtons, and the resistive force is 3,000 newtons. The velocity of the car at this instant is 24 meters per second. What is the power output from the engine? Of course, the power from the engine should be force times the velocity. So the force here is strictly going to be the output for the force from the engine without subtracting the resistive force, because the force from the engine must overcome the resistive force and also move the car. So this is going to be 12,000 newtons times the velocity, which is 24. So this is going to be 12,000 times 24, that is 288, which is approximately 290 Kelvin. 288 kilowatts, not Kelvin, which is approximately 290 kilowatts. So the answer is going to be C. The diagram shows the variation of a quantity y with a quantity x for objects in a uniform gravitational field. Uniform gravitational field. That means the acceleration is constant. The acceleration, it's a uniform gravitational field, which means the acceleration is going to be constant. What could x and y be? Okay, what could x and y be? The first one says kinetic energy. Kinetic energy, let's check. We know kinetic energy is equal to a half mv squared. Of course, kinetic energy is directly proportional to v squared. So that will be a curve. You can check if you want v and ek. When v is 0, ek is 0. When v is 1, ek is 1. When v is 2, ek is 4. When v is 3, ek is 9. You notice that ek increases more rapidly than v. So that is a curve going upwards. So most likely we can say y is kinetic energy, and then x should be the speed. That is a curve of increasing gradient. So it cannot be. If we say mass of different objects moving at same speed and kinetic energy, we see that kinetic energy is directly proportional to m. That means this will be a straight line. If it was if x was mass and y is kinetic energy, this will be a straight line. So A is out. If x is speed at a constant mass and y is kinetic energy, this makes sense. So that is a curve of increasing gradient. A steel wire has length 300 centimeters, which is 3 meters, of course. This is 3 meters. And a cross-sectional area of 0.5 millimeters squared. The Young modulus of steel is 2 times 10 to the power of 11 pascals. One end of the wire is attached to a fixed point. A load of 10 newtons is hung from the other end. The wire obeys Hooke's law. What is the extension of the wire? So Young modulus is stress over strain, which is force over area, times we get the reciprocal for strain, which will be original length divided by extension. So the Young modulus is given as 2 times 10 to the power of 11. The force is 10 newtons. The cross-sectional area is 0.5. Of course, I have to change this from millimeters squared to meters squared. So this would be times 10 to the power of minus 6 to change it to meters squared. Times 10 to the power of minus 6. Then times the extension times the original length, which is 3 meters. So I'll just press my calculator. I'll have 10 times 3 divided by 0.5 exponent minus 6 divided by 2 exponent 11. So this is 3 times 10 to the power of minus 4. E is 3 times 10 to the power of minus 4. I just made E the subject in my calculator directly. So the answer here is going to be C. The extension of a copper wire is measured for different forces applied to the wire. A graph is plotted to show the variation of the force on the wire against extension. The maximum force is applied at point P. Maximum force is applied at point P. Which statement must be correct? Point R is the limit of proportionality. Limit of proportionality, it must be where the straight line stops. So this is not correct. The elastic potential energy of the wire at point S is given by the area under the graph between points T and S. Of course, the area under the straight line part is the elastic potential energy, so this is correct. There is no plastic deformation between points Q and P. Of course, after Q and P, there is plastic deformation, so this statement is wrong. The wire obeys Hooke's law up to point between R and Q. The wire only obeys Hooke's law up to point C, so this statement is not correct. So the answer is B. For Hooke's law to be obeyed, it must be a straight line, so it stops at point S. The variation with the distance x of displacement y of a transverse wave on a rope is shown at t equals to 0. The wave has a frequency of 0.5 Hertz, which means the period is going to be 1 over 0.5. I think that is 2 seconds. That is the period. At point P on the rope is marked. A point P on the rope is marked. The diagram shows the original position of P and the 4 new positions. What is the position of P at time t equals to 1 second? So at time t equals to 1 second, I think 1 second is equal to half. The period is 2 seconds. 1 second is half a period. So if a point P is marked on a rope, so it is moving up and down. So a quarter of a period, it goes to point A, and another quarter it moves to point B. So 1 second is half a period, so it will be at point B. So the answer is B. Because P is a point marked on the rope, and it is moved as the rope vibrates up and down, P moves up and down. A quarter cycle, it will go to equilibrium, another quarter it goes to maximum displacement. So it has moved half a cycle. The answer is B. A cathode ray oscilloscope is connected to a microphone which detects sound of constant frequency. Constant frequency. The trace on the screen of the CRO is shown. Which property of the sound wave is measured using only information from the CRO? So from the CRO we tell the amplitude, only information from the CRO. The trace on the screen of the CRO is measured, which detects sound of constant frequency. Okay, so we can't see wavelength from the trace. We cannot measure the speed of the sound wave from the trace. Of course, which property of the sound wave is measured using only information from the CRO? Because the sound has a constant frequency, then we can tell the period from the trace. Only the period. We cannot really tell the amplitude. Since sound has a constant frequency, we can tell the period from the trace. A transverse wave and a longitudinal wave both travel in the same direction down a long stretched string. A long stretched spring, okay, long stretched spring. Of course, the transverse will move, the rope moves up and down. Then, the spring would move up and down, and the longitudinal wave, the spring coils will move forward and backwards. Which statement is not correct for the two forms of waves? The displacement measurements for the particles of the two waves are made at right angles. Displacement of the particles, that is correct. Because for transverse, we shall measure the displacement, say, vertically upwards, yet for longitudinal, we shall measure the displacement horizontally. So they are made at right angles to each other. The energy transferred by the two waves is in the same direction. Of course, this is correct. Although the vibration of the transverse are up and down, energy is in that direction. And then the vibration of the longitudinal is forward and backward, energy is in the same direction. So the energy is in the same direction. The velocity of the two waves are in the same direction. This is also true. The velocity of the wave is the same direction as that of propagation of energy. Then the wavelength measurements for the two waves are made at right angles to each other. Okay, of course, for wavelength, if this is a transverse wave from the rope, the wavelength is measured in this direction. And if you have a longitudinal wave where you have the troughs together and points of maximum and then minimum, the wavelength is measured like this. So they are parallel. So they are not right angles. So this statement is not correct. A man standing next to a stationary train hears sound of frequency 400 Hz emitted from the train's horn. The train then moves directly away from the man and sounds its horn when it has a speed of 50 meters per second. The speed of sound in air is 340 meters per second. What is the difference in the frequency of the sound heard by the man on the two occasions? Okay, so if it is moving towards, the observed frequency is going to be V over V. Because it is moving, the train then moves directly away, so it is plus. The observed frequency is going to be lower than Fs. So what is the difference in the frequency of the sound heard by the man on the two occasions? So this is going to be equal to 340 divided by 340 plus 50. Then I multiply this by 400. So 340 times 400 divided by 340 plus 50. So that is 348.7. So this is 348.7 Hertz, or which is approximately 349 Hertz. But then we want the difference. So the difference in the observed frequency is going to be 400 minus 349, which I think is 51. So the answer is going to be A. Which list of regions of electromagnetic spectrum is in order of increasing wavelength, left to right? Remember, Reed's mother is visiting Uncle Xavier's garden. So increasing wavelength. Wavelength increases in this direction. This is increasing wavelength. That is increasing wavelength. So it means if gamma rays comes first, that will be wrong, because we want increasing wavelength from left to right. Infrared has a shorter wavelength than microwaves. Oh, sorry. Increasing wavelength from left. Okay, gamma rays have the shortest wavelength. So the answer is going to be A, not any of the others. Because we want increasing wavelength from left to right. Wavelength is increasing from left to right. Gamma rays followed by ultraviolet followed by infrared. So gamma smallest followed by ultraviolet followed by infrared. So the answer is A. The answer is automatically A, increasing wavelength. The principle of superposition states that a certain quantity is added when two or more waves meet at the point. Of course, that quantity is displacement, so that the resultant displacement is the sum, the algebraic sum of the individual displacement. So the answer is B. A stationary sound wave is formed in a gas-filled tube of length L, which is closed at one end by a piston. The length of the tube can be altered by moving the piston. The length of the tube and the frequency of the sound are varied so that the stationary wave always has two antinodes and two nodes. Okay, So we can first of all establish what the length stands for here. This is a half plus a quarter. Half plus a quarter, those are 3/4 of a cycle. So this is 3/4 wavelength, which means the wavelength will be 4 times the length L divided by 3. That is the wavelength. The length of the tube and the frequency of the sound are varied so that the stationary wave always has 2 antinodes and 2 nodes. The graph shows the variation of the frequency f of the stationary sound wave with the length L of the tube. Okay. What is the speed of sound in the gas in the tube? So I'm just going to choose a favorable number here that I'll use for my calculation from the graph. I have to look for a point where the line crosses carefully. Okay, so I will choose, let me take this point here. Okay, I will take that point here. And this corresponds with this value on the x-axis. So 5, 6, 7, 8. This is 8. On the vertical, each box is 1000 divided by 5. 1000 divided by 5, 200. So I'll subtract 200 from 3000. So this box is 2800. Okay, so when F is 2800, L is 8 centimeters. So what is the wavelength? So the wavelength is going to be 4 times 8. The units are centimeters, so it is times 8 times 10 to the power of minus 3 divided by 3. Okay, so this is going to give me 4 times 8 exponent minus 3 divided by 3. Okay, so that is going to be the wavelength. Let me leave it as that, meters. Then we want the speed of sound, so I'll use V equals to lambda times F. So the wavelength is 4 times 8 times 10 to the power of minus 3 divided by 3, then times F, where F, the corresponding value of F is 2800. So I'll say that answer times 2800, which is giving me did I press this correctly? 4, here I said minus 3 instead of minus 2. That is minus 2, not minus 3. So I'll repeat 4 times 8 exponent minus 2 divided by 3 times 2800. Okay, that is 298.6 recurring, which is 299 or 300 meters per second. So the speed is going to be 300 meters per second. So that is C. You could use any other value as long as you choose a point which is clearly at the center of, you could choose this point here with against 5 and check if you could get the same answer. The diagrams show the diffraction of water waves in a ripple tank as they pass through a gap between two barriers. Which diagram is correct? Of course, diffraction is maximum if the size of the gap is directly proportional, is almost the same as the wavelength. That's when diffraction is maximum. So, which diagram is correct? So here I notice that when I compare this wavelength to this size of the gap, of course the wavelength must remain the same. Lambda stays the same after when diffraction occurs. Lambda stays the same. Here we see that the wavelength has reduced here. So wavelength here has reduced. So that means this is not true. The wavelength remains the same. Here, when we compare this to this, it's like the wavelength has increased. This one is also wrong. Wavelength increased here. Wavelength should stay the same. When I compare this and this, it is almost the same, so the answer is going to be B. This is wrong because here it shows that the wavelength reduced. The wavelength must stay the same, so the answer is going to be B. The wavelength lambda should stay the same. Lambda same after diffraction. So the wavelength should stay the same after diffraction, which is the case here. A beam of light from a laser is incident normally on a double slit. It is a double slit. Interference fringes are seen on a screen placed parallel to the double slit. Of course, when you hear double slit, the first thing to come into your mind is lambda equals to AX divided by D. The separation of the two slits is A, the distance between the slits and the screen is D, the distance between the centers of two adjacent bright fringes is X. D and A are both halved. What is the distance between the centers? So we already have this equation here. This means X is going to be lambda times D divided by A. So for the first one, let this be the first equation. For the second equation, what is the distance between the centers of the two adjacent bright fringes? That is X. For the second one, after these changes, which changes are those? D and A are both halved. So X2 is going to be, wavelength is staying the same. D is now a half D. A is now a half A. So of course a half and a half are cancelling, and this is taking me back to lambda D over A, which is the same as before. So it is going to still be the same X. A beam of light of wavelength 400 nanometers is incident normal on a diffraction grating that is 3000 lines per millimeter. So we change this to lines per meter, which will be 3000. If 1 millimeter has 300 lines, then how about 1 meter? 1 meter is 1000 millimeters. So I'll multiply this by 1000 to get the number of lines per meter. Of course, this is going to be times 10 to the power of minus 9 in meters. Okay, what is the total number of maxima? If we want to find total number of maxima, then remember for a diffraction grating, n lambda is equal to d sine of theta. For n maximum, sine theta should be equal to 1. That means theta should be equal to 90 degrees. And for this one, therefore, we are finding, remember there is central maximum, then we are finding maximum value of n from the center. There's also n above. So we want maximum n here, then plus the one at the center. So it means n is going to be equal to d. Remember, d is equal to 1 over n, capital N, where n is the number of lines. So this is going to be 1 over 300,000, of course, times 1, divided by lambda, which is 400, times 10 to the power of minus 9. So this is going to be 300,000 times 400 exponent minus 9, then 1 divided by the answer, which is 8.33. So we round off to the smallest whole number, which is 8. So the total, we have 8 above plus the central bright fringe plus 8 below, which is going to give us 17. So our answer is going to be D. Two wires X and Y are made from the same metal. That means resistivity is the same. The diameter of wire Y is twice that of wire X. What is the ratio average drift speed? X and Y where X, wire, Y, and the battery are connected in series, that means the current is the same. They're in series, the current is the same. What is the ratio average drift speed of free electrons in wire X over average drift speed of free electrons in wire Y? Remember, current is going to be equal to never, but the current is the same. So let's start with X. For wire X, we have n number of free electrons because it is the same material times the charge of each electron. Average drift speed will be Vx. Diameter, we know that area, this is area. Area is equal to pi d squared divided by 4. So I'll say times pi for x. The diameter of wire Y is twice that of x. Let for x be d and for y to be twice d. So this will be pi d squared over 4 should be equal to n e v for y times pi. Diameter is twice, so this is twice d squared divided by 4. So n e pi 4. So we have Vx times d squared is equal to Vy times 4d squared. D squared has also cancelled. So it means Vx over Vy is going to be 4 divided by 1, which makes our answer to be automatically D. A resistor has resistance R. When the potential difference across the wire is V, the current in the resistor is I. The power dissipated in the resistor is P. Work W is done when charge Q flows through the resistor. What is not a valid relationship between these variables? Okay, let's check one by one. This one, power is equal to IV. This is correct. This one, it means work done is equal to, when I make V, okay, if I make V the subject, V is equal to work done over charge. That is the definition of V. This is a correct relationship. When I make P the subject, P is equal to I squared times R. We are used to this. So this one is not correct. The correct one would be power equals to V squared over R. So this one is not correct. Because I said what is not a valid relationship. So D is not valid. A fixed resistor and a filament lamp are connected in series to a power supply. The IV characteristic for the two components are shown. Okay. Because they are in series, so I is the same. The current is the same. They say the current in the fixed resistor is 0.34. So I will look for 0.34. The scale here is 0.1 divided by 5. Which is 0.02. So I will add two boxes to get 0.34. Okay, 0.34. So I'm finding the PD here. On the x-axis, it is 2 divided by 10, which is 0.2. So this is 4.2. That is the PD there. Remember, the current is the same. So 0.34, I'll add two boxes. And this is giving me 6. Okay, the PD here is 6. Remember, they're in series. So what is the resistance of the filament lamp? So resistance is going to be V over I. And V is equal to 4.2 divided by I, where I, of course, the current is the same. The current in the fixed resistor is 0.34. And of course, the current is the same. So this is going to be 0.34. So 4.2 divided by 0.34. Why did I use it on the second graph? The first graph. So this gives me 12 point something. So which is approximately 12 ohms. So the answer is going to be B. A piece of conducting putty modeling clay of constant resistance is formed into a cylindrical shape. The resistance R between its flat ends is measured. the same volume of put is reformed into cylinders of different lengths, and the resistance R between the flat ends is measured for each value of L, which graph best shows the variation of R with L. Okay, so the resistance is equal to rho L over area, and of course area or volume is the cross-sectional area times the length. Remember, V is the same. So it means area is inversely proportional to L. Area is inversely proportional to the length. Okay, so it means if the area decreases, if area is reduced, no, area is inversely, not directly proportional. If area is decreased, the length must increase. And if L increases, then the resistance must increase. After all, the change, because the area times the length must be the volume, if the area decreases, the length must increase so that the product is always the same. So if area decreases, the resistance is going to be increased. But you should also note that the change in area is, since the change in area is very, very small, as L increases. The change in area is very small as L increases. It means instead R will not increase, the increase in R will not be a straight line. So R increases exponentially. Instead of being a straight line, R increases exponentially. Or it increases more rapidly. I've just used that. R increases more rapidly. So this one is wrong. This is a straight line. This one is showing that as L increases, R increases and then becomes constant. That is wrong. As L increases, R increases more rapidly because the change in area is very small as L increases. So the answer is going to be D. The diagram shows the symbol for a component that may be used in an electric circuit. Of course, this is a buzzer. Without even thinking twice, it is a buzzer. If it was a microphone, I think it would be something like this. Loudspeaker, something like this. Which row correctly describes Kirchhoff's laws? Remember, first law, sum of currents entering a junction equals sum of currents leaving a junction. That is the first law. Second law, of course, the physical quantity is charge. Second law, sum of EMFs equals sum of PDs in a closed loop. Conservation of energy. So the answer is automatically A. Conservation of charge, first law. Conservation of energy, second law. So this one is wrong. And second law is conservation of energy. But then second law is sum of EMFs, not sum of currents. So the answer is A. Then 38, that is, I think, 38 is still electricity. A potential divider circuit is formed by connecting a battery of negligible internal resistance in series with the two variable resistors. They're in series, so the current is the same. The variable resistors have resistances Rx and Ry. Vx is the potential difference across variable resistor with resistance X. With resistance Rx. Rx and Ry are both changed at the same time. Okay? Which combination must cause Vx to increase? So note that Vx is going to be the current times Rx. So we want Vx to increase. Definitely Rx should increase and Ry should decrease. Because the same current is going to go through them, Rx should increase as Ry decreases if we want Vx to increase. So Rx should become larger and Ry should become smaller at the same time because they are sharing the power supply. So if we want Vx to be bigger, then Ry should be smaller so that the PD across Ry is smaller, which makes the PD across Rx bigger. So the answer is going to be B. An actinium nucleus has a nucleon number 227, proton number 89. It decays to form radium nucleus emitting beta minus and an alpha particle in the process. What are the nucleon number and proton number of this radium? Okay, so let's call the other one X. I don't need to know the symbols. X is 22789. It is going to give us Y, which is radium, plus beta minus, that is 0, negative 1, plus an alpha particle, which is 42. So this one, we should balance the proton number. This will be 227 minus 4, which is 224. So 223. This is 223. Then proton number, this is 89 on the left-hand side. So we have 89 minus negative 1 plus 2, which becomes 88. So this should be 88. So proton number should be 88. Only one answer has proton number as 88. This is 223. So the answer is going to be B. Which statement is not correct? Which statement is not correct? A meson consists of 3 quarks. That's not true. A meson has a quark plus an antiquark. So that is not true. A proton is a baryon. This is true. A quark is a fundamental particle. That is true. There are 6 flavors of quarks, which is true. We have up, down, top, bottom, strange, and charm. So the answer to this question is going to be A. Which statement is not correct? The first one is not correct. Okay, I think that marks the end of multiple choice May June 2022. If you have any question, you can always ask. I have a big stop there. Until next time, bye bye.